I'll present kind of the view from England, the view from the Environment Agency, but I think the challenges that we cover will probably cover most of the devolved admins and others who look and gather data. And I think just starting from this, we just touch on some of the challenges that we face, things that we think about as we move through this process. And really, most of our monitoring, it's about understanding really the questions that we are trying to answer and trying to allocate the resources appropriately. And in many instances for us, that's around looking at the kind of two kinds of core program we have, our long-term monitoring networks and the more targeted pieces of work that we do, and actually working out the balance between those, and they are both equally important in terms of developing that broader picture of what we want from the environment. But that gives us a picture, gives us a snapshot, tells us what's happening. Is it getting better, is it worse? But there's another area that I think we've started to touch on this morning, which is actually, why is it getting better? Why is it getting worse? And we only have so much information that helps us with that. And actually there's a huge amount of other data and information that sits behind that really helps us to explain what's happening, why it's happening, and what we do in the future to kind of more proactively manage the environment. And I'll use that term quite a lot, which I think is a better way of doing things, certainly. So, some of the kind of challenges that we face, I suppose, when really looking at our monitoring programs, our ability to target our resources where they are most needed. So, I think our traditional approach really is, broad-scale monitoring programs. We look at what's pass and fail, we target in the kind of fail areas. But actually, there should be a better way, given the amount of information we know about pressures on the environment. Our risk assessments that we have, certainly through Water Framework Directive, and as we take this forward, tells us where pressures are changing. And actually, do we need to wait for something to be broken before we actually do something? Should we not respond to those more effectively and really start to think about how we target our monitoring more effectively? And actually, the long-term programs actually really help with some of that as well, in terms of building that picture, and depending on the levels of granularity we can get down to, really focusing in on some of the key issues that we face, and therefore what we should do about them. Certainly understanding the impact of current pressures, but certainly new pressures. Again, we're aware through new pressures, through this volume of other data that's around, how we integrate that, where those are coming through, and how we make sure we are monitoring in a sensible way to be able to capture those impacts. The real value of some of those long-term data sets that sometimes you don't realise the value of it until you start to look at some of the other things that you want to look at. So really, really key in doing that, but making sure we secure that. And demonstrating the benefits and value of the improvements that we make. And to do that, really, that again is around linking various bits of data set. Yeah, so we know things improve, but why do they improve? And actually, if we want to understand the benefit, value, economic value of some of the policies that we put in place, we need to understand and make that link between policy, changes to behaviour, and therefore impact on environment. You need that link. It's really key. Because that also then generates a view around success, and therefore further investment when you might need it. So really, really key to have that understanding. Now, I guess over time, the way that we've looked at things is as a mass of data, and monitoring has changed over the years since the Water Framework Directive, where it becomes much more targeted and risk-based. And unpicking those signals in an ever more complex environment becomes quite difficult, because there's a lot of bias introduced, and rightly so, depending on what your monitoring programs are there to do. So, part of the process that we're going through as an organisation now is starting to unpick that and say, actually, okay, so where do we put our resource? What questions do we ask of our programs? We need something that's better, that's more representative in terms of our long-term programs, things that we pick up over time. So we can say with a level of confidence, is it getting better, is it getting worse? And then start to add to that around why. But we also have the right levels of resource in place to target action to deliver the improvements that we've got. I think the good news that comes from that actually is a long-term monitoring program is a really key part of that. I think the organisation recognises that more so than ever now, but it's absolutely key that we have that from our own organisational perspective, but from a broader perspective across the people sat within this room. And that the two work together. Joining these things up, long-term targeted other data sets, becomes ever more important. So how do we do that? So let's start off with the impact piece. So long-term monitoring programs aren't something that are new. We've had numerous of them for a long, long time. Sometimes can be quite restricted spatially, sometimes can be quite targeted at specific things, low pollutants into the sea, something akin to that. But I think what we recognised was, even with the surveillance network under Water Framework Directive, there were real limitations in terms of the requirements that it asked us to deliver, and were we really getting a picture around the state of the freshwater environment from the kind of data sets that we had and what we're trying to unpick. So, GRTS, I'm going to have to read this because I always get it wrong. Generalised, randomised, tessellation stratified, and we will test you at the end. Effectively, a monitoring design tool, methodology, that generates a set of sites which are representative of a target population. That term target population really quite key in respect to this. It effectively avoids clumping, so clumping, grouping of sites together, which you can sometimes get when you have something that's completely random, or you ask people to try and start looking at long-term data sets and where they want to locate sites, because they'll always pick their favourites or things that are of specific interest. And the key for us is it allows inference to be made at the condition of that whole target population. It was a system designed by the US EPA. US EPA use it, Marine Scotland use it, and a lot of the work that we have done in designing the proposed network that we have was done with Glasgow University as well. So it has some credibility behind this, and we hope in the longer term that it will be a kind of real asset, not just to us, but to a wider range of communities in the data set that this provides. It should be open data results. There should be a lot there that people can use and add to be able to deliver that richness of information. A few kind of key points within it. That target population depends on the map scale you use. So if you use a very high density network, you end up with an enormous number of very, very fine rivers, the headwaters, etc. And the system, if you want to make it so the number of sampling points are representative of that population, you'd end up with a huge number of sampling points targeted at the headwaters and very little else. So it's about using the right map scale to get something that looks like the right population. We use the 1 to 250k. That gives us a fairly sensible mix of the kind of main rivers that we're interested in, where a lot of the impacts are, but we now cover more of our headwaters that we never really did under Water Framework Directive, but still cover the lower stretches as well. And that network design around particularly the site selected mirror the length of stream, so it's kind of no bias in that sense. But those basically the site numbers selected mirror the length of the river in each order. So we do get that balance of resource right the way across the different lengths of stream, and they are sensible in how they represent our population. The other bit that we would raise on that bottom left side is this concept of a panel design. So actually this works differently in the sense that if we say we pick 500 sites, 100 or so sites we visit year in, year out, same place, but then we have panels, we call them panels, representative 400 sites that go across that river design. One panel in year 1, then a different panel in year 2, different panel in year 3, different panel in year 4, then we rotate back. It starts to give you a very, very good spatial coverage of the whole river network that we've got in different sites, but also gives you that temporal continuity as well. So it starts to really kind of build up the picture that I think we need in a really unbiased way around actually how things are getting better. 500 is the number that we've chosen based on expert design at the moment. Benefit of this network is you run it and you test it. You test it to understand what it's giving you. We can change it, we can amend it in that sense. Things that we measure, probably very traditional in respect to Water Framework Directive. We have Water Framework Directive methods, etc. So it can feel quite conservative with a small c in terms of the things that we measure, but we have tools and techniques, classification tools to how we manage the data. Doesn't mean to say that we can't add to these sites in the future and use new things, measure new things to build on that infrastructure, that panel of sites, as new technology comes forward. I think the exciting bit, the innovation bit, comes with actually what you do with that data as you start to have a look at what it really means and the different scales that it operates on, and it does operate on a different number of scales there. So I think that's a picture of innovation, new approach for us. We feel traditional in some senses, but a real strong statistical basis for how we look at state of the environment moving forward. The other area, I guess, that we then need to look at, which is the other part of the story that we talk about, is this concept around evidence for decision making. So that kind of broader picture. So the impact monitoring really is part of that jigsaw. But it doesn't really tell us why things are changing. I mean, these are the kind of things that we've touched on from the first two speakers today around how you join up data. And that could be joining up environmental impact data from other monitoring programs that we have to really build that picture. But actually really understanding why things are changing actually is a whole range of different elements of the data, from social, from economic, land use, to a vast array of data that we have. That really helps to explain why things are changing and where they're going in the future, where the risks are, so we can really start to look around what the opportunities, where the threats are, and what we actually do about that. I think that's really key, and I guess the challenge that I put forward today is really for everybody that sits in this room. It's for this kind of thing to happen. How do we bring data together? Is our data discoverable? Can we easily share all the data that we have? If we want this to work, and we are committed to making it happen, and this has been a tenet, I think, of UKEOF for a very long time, in terms of sharing stuff through their catalogue and the kind of concepts behind sharing data. We all have that responsibility around actually, is our data open? Is it discoverable? Can we use it? Is it usable in a way that we can all make use of it? The answer isn't one archive, by the way. There isn't a central hub. Let's not go there. But the ability to link data sets, using the kind of innovation around how you link data sets together to make this better, is absolutely there. Help with how we do it, so how we integrate data. This is a concept for us. We don't have the answer. So actually there's some learning here today around how we come together and actually be able to deliver that. And I think the last bit we talked about was innovation. We talk about innovation in monitoring. We've seen some examples up there of how we can integrate, how we can allocate to DNA, we can use satellites, a whole range of different levels of instrumentation. My current world is in air quality, looking at different techniques and technology for that. But we need to invest in the innovation around data. It's not to get the data, we can gather as much as we want, but we don't use it, and use it creatively and combine it. That's key. So let's think about innovation in data management, data integration, how we turn it into really useful information. I'm looking forward to learning from others today. I know my piece, but I'm really looking forward to hearing what everybody else has to say and working out actually how we get this to happen and how we move it forward.